Yeah, hi, welcome everybody. In this video, we are dividing into a world of networking to understand two important concepts of MTU and MSS. So these terms might be sound like technical, but don't worry, we will break into the simple terms. So let's get started. So in this video, we will discuss like what is MTU, what is MSS, the difference between MTU and MSS, why MTU and MSS are important, and how to check and configure MTU and MSS value. Now let's discuss about the what is MTU. First up, let's talk about the MTU, like which stand for maximum transmission unit. So think of MTU is a maximum size of package that can be sent over a network. Just like when you are sending a package through mail, so there is a limit how long, uh, how big the box can be. So same way for network packets, like MTU is the limit on how much data can be packed into single packets, and that's get sent over the network. For example, quick example, like imagine you are sending a big file over the internet, and your file will be split into small chunks called packets. So to travel through the network, the MTU is maximum size of this chunk. So if your MTU is too large for network segmentation, then packet might need to be broken down further. So which can be slow the things down. So the standard MTU size of many network is 1500 bytes. Okay, so here we can see like there is a one big file for us like 10,000 bytes. So which need to be divided into some small of packet, like packet one, packet two, packet three, and packet n. Okay, so each packet has a maximum size defined by the MTU. So each packet consistency of header and data of chunk. Okay, and the size of data chunk into each packet is determined by the MTU minus the size of header. Okay, so here is the diagram, like for example, the data packet, right? So in data packet, uh, there is MTU limit like 1500 bytes. So uh, the MTU value will be exceed. So what will happen? It will convert into fragmented packet one, and for exceed MTU, it will convert into fragmented packet two. So here we see right fragmented packet one, packet two, packet three, and packet one. So this is the real world scenario example when the when we are sending a big file over the internet or transferring the big file over the internet. In this video we will discuss about what is MSS. Okay, so now let's move on to MSS. So which stand for maximum segment size. So MSS is closely related to MTU, but especially refer the maximum amount data can be sent into the data portion of the TCP packet. Okay, uh, so MSS is the actual size of data, excluding all the headers. Okay, so here, for example, this is my IP packet, right? So in IP packet, there is IP header and TCP segment. Okay, so in TCP segment, there is a TCP header as well as and the TCP data. So this TCP data is, we can say that is it's a actual MSS size. Okay, so if M2 is the size of entire box, you can send through the mail. So MSS is the size of content inside the box after your account for the box itself. So in networking, box include header and other information needed for the packet to travel, while MSS is just actual data inside. So to keep things in efficient, like the MSS is usually set for slightly smaller than MTU to leave a room from the header. So for example, if your MTU is 1500 bytes, then the MSS might be 1460 bytes, while remaining the 40 bytes is used for TCP header and IP header as well as. So data is actually a 1460 bytes. So for example, the data packet include means IP header, TCP header, and payload. Payload means TCP segment, means MSS value, actual MSS value. For example, Ethernet header is 40 bytes, IP header 20 bytes, TCP UDP header is, for example, for TCP 20 bytes, UDP 8 bytes. Remaining payload, which we can say that like actual data is 1460 bytes. Okay, so this is the actual. You will understand like MTU is the entire box or entire packet size, while MSS is actual payload, which is inside the box, like inside the MTU value. So MSS is typically negotiated automatically during the TCP handshake and isn't directly configured like MTU. So, however, but we can set the MSS value in network device as well as in uh, all the network device. We can set that MSS value. Okay, so for example, if you are aware about the TCP three-way handshake, so if client or client and server, when client is sending a SYN packet during that time, MSS value will be automatically negotiated automatically. Okay, if we haven't watched or aware about the TCP three-way handshake, just go to my YouTube channel and just check out the TCP three-way handshake video. So this is the MSS value where we can negotiate it during the TCP 316. So if you see the packet capture, so in packet capture, okay, so here this is the packet, right? So this is the TCP and SYN packet, right? So in this SYN packet, maximum segment size value is defined, like MSS value is defined. Okay. Now let's discuss about the difference between MTU and MSS. So MTU is the maximum transmission unit and MSS is the maximum segment size. So MTU is the maximum segment size of entire packet that can be transmitted over the network. Okay, and MSS is the maximum amount of the data that can be sent into data portion of the TCP packet. This is the definition. Now include like what's included in MTU. So it's include IP and TCP header and actual the data portion, where MSS only the data portion of the TCP packet. The typical size of MTU is 1500 bytes standard, where MSS is the 1460 bytes typically. It's always dependent on the MTU value because we have to exclude header as well as networking header like IP header, TCP header. If we are using IPsec VPN, then we have to exclude the IPsec VPN header as well as. It's always dependent on the MTU. Now component like MTU like IP header, TCP header plus data, where MSS is the actual data. The purpose of MTU like ensure that packet size is within the limit of the network transmission capability, where MSS purpose is optimize the amount of data sent in each segment to avoid the fragmentation. Relation like what is the relation between MTU and MSS? So MTU is equal to, we can say that MSS plus IP header plus TCP header. Same applicable to MSS like in reverse way, like MSS is equal to MTU minus IP header minus TCP header. Overhead. So account of the entire packet include the header, where MSS is only focused on the data payload, reducing the overhead. Now impact of headers, like header are included in the MTU calculation, where headers are excluded in the MSS calculation. So fragmentation, like if the MTU is too large for network segmentation, the packet may need to be fragmented. So for proper MSS setting helps avoid a fragmentation by fitting the data within the MTU. A configuration MTU we can configure at a network layer, where MSS value will be configured at transport layer. So additionally, this question interview can be asked during the MTU and MSS operate at which layer. So you can say MTU value operated near network layer, MSS value operated for layer 4. So we discussed right during the TCP handshake, during the SYN packet, MSS value automatically negotiated. That can we can set them manually as well as, but by default it's automatically negotiated during the TCP 316. Now let's discuss why MTU and MSS are important. So we can use real world scenario example. For example, imagine you are streaming a video from your favorite online service like YouTube or Netflix. Let's see how MTU and MSS are help ensure you have a smooth viewing experience without buffering or interruption. So now MTU in action, like for example, you are at home using your home Wi-Fi to stream a video. So the video data is sent in a package from a streaming server to your device. Okay, this is the example scenario. Now let's understand the importance of MTU. So think of MTU as a size limit of each of this packet. For example, the standard MTU size of many network in 1500 bytes. Okay, so if packet are too big, they need to be split into smaller pieces to fit through a different part of networks, which can be slow thing down and cause a buffering as well as. Now let's discuss about the MSS in action. So in example situation, like when your device connected to streaming server, they are agree on how big the data chunk MSS should be inside the each packet. So importance of MSS, like MSS ensure that the data chunks are small into fit within the MTU size. So leaving a room for other information that help the packet travel, like addresses and interaction, we can say that. So MTU, this is the data chunk. Okay, so data chunk means MSS value, or in simple diagram, you can say here inside the data packet. Uh, okay, TCP segment, TCP data. So this is the MSS value. Okay, so for standard MTU, like 1500 byte, and MSS typically we have to exclude the header. So IP header, TCP header, so 1460 bytes. Okay, so this help the video data travel smoothly without needing to be split or preventing the interruption. Okay, so if what happen if incorrect MTU setting or incorrect MSS setting. So if MTU is too high, packet might be split along the way. This can cause a delay, buffering, making your video stop or start. Incorrect MSS setting, like if the MSS is too large, the data chunk won't fit within the packet, within the MTU value, so causing them to be split, which can be also lead to be buffering or interruption. Okay, so if within the proper MTU and MSS size, the video data is sent to well-sized packet that travel efficiently, giving you smooth and high-quality streaming experience. So by understanding this and correctly this setting in MTU and MSS, network admin or service provider to ensure that data travels smoothly, uh, enhancing our experience in real-world application like video streaming. Now, how we can check the and configure MTU and MSS. So first, let's discuss about the Windows. So in Windows, there is a command netset interface IPv4 show sub interface. We will check it in our Windows system as well as to configure netset interface IPv4 set sub interface. Mention the interface name, MTU value, and store persistent. Okay, so now let me open CLI of Windows. To open command prompt in Windows, you need to press Windows R and then need to type a CMD. Okay. So and after that, you have to enter this command at state interface IPv4. So sub interfaces. Okay. So in this case, you look at the MTU column to see the current MTU value for your network interface. For example, I connected this via Wi-Fi, then Wi-Fi MTU value will be this. Okay. Same way, you can check for other sub interface as well as. Okay. This is my 0 tier 1 application. This is different, but you can ignore this one. Okay, so if we need to configure the MTU, then we have to use like netstate. Okay, command. Just a minute, like this. I am unable to copy. So like this netstate interface IPv4 set sub interface. Here I have to mention the interface name. For example, I have to mention like I have to change for Wi-Fi or Ethernet. I have to mention that name, MTU value, and store persistent. Okay. Right now I'm not connected with a local line. That's why it's giving error. And after that, you can also, after configuring this MTU value, you can cross verify using this same command, this command. Okay. For MSS value, MSS is typically negotiated during the TCP 3-way handshake, so isn't directly configured. But if you want to check the MSS value, you can do one thing. You can capture the packet and you can open that capture in packet in Wireshark application, or you can use the TCP dump as well as. Okay, so just let me show me. Okay, so this is the one of the TCP 3-way handshake example. So in during the first packet, like during the sync packet, the MSS value automatically negotiated. Okay, or else you can download the or you can use the TCP dump. Okay, so in TCP dump you can filter out with the flags. So in sync flag you can identify the MSS value. We have to check the sync flag on TCP sync flag. Okay, and that packet that information will contain the MSS value. Okay, now for Linux, I don't have any live terminal right now, but you can make a use of IP link. So and specify the interface where you have to check the MTU value. Okay, for example, Ethernet 0, 1, 2, 3. If in this example, I have to check on Ethernet 0. That's why I mentioned Ethernet 0. Same way to configure, you can use the sudo IP link set the interface value, MTU and MTU value. Okay. So like that way, you can configure the MTU and MSS value we can configure as well as, but by default, it's automatically negotiated. Okay, let's see how we can configure in Windows. So in Windows, I need to click on Windows R and then type page edit. After that, you need to click it. It will open the registry. Okay. And this registry, you have to go to this path, interface, computer, local machine, system, current control set, service, recipe, parameter, and interface. Here you have to click add the new value like this, and you have to mention the value. Okay, so this is the one example where we can configure the MSS value in Windows, but we are not preferring it generally. This is the, I'm just giving the simple like, okay, and after that, you require a reboot. Okay, so